Okay, welcome to Circuit Lab session 4. Okay, so what we're going to cover here is a variety of different ways the examiners are going to trick you in terms of the different problems they'll pose towards you. So we're going to take a look at a couple of them so you have a sense of what they're going to do so you're well prepared. Okay, so let's go ahead and get started. Um, the first problem that I'm going to put up is going to be a very simple circuit with two resistors, or maybe rather even three resistors. And in those three resistors, um, we are going to find 3 points. And in those 3 points, what we're going to do is find whether the current is the same or current changes. Okay? So now let's go ahead and get started. Let's take an example of three different resistors. Okay? So you have 5 ohms, 10 ohms, and 15 ohms. Okay? And we're going to supply a power of um, 30 volts. Okay, this is the positive and this is the negative. All right, so this is what the examiners are going to post to you. Okay, they're going to go and let's say they take an example and they're going to say, alrighty, so you have 4 points here. We're going to label them A, B, C, and D. Your code, the question they're going to ask is, what is the current at point A, at point B, at point C, and point D? So what is the current at these 4 points? Okay. Now, this essential problem is there to confuse you, right? Which is the moment they put a circuit like this together and put A, B, C, and D, you think that maybe the current is going to be different across the board, okay? But now let's go through the current a little bit, okay? So the first thing I think you guys need to realize is don't think about what the examiner is asking, just think of the resistors themselves. If you look at the three resistors here, first question that you need to ask, okay, are they in series? Yes or no? Or are they in parallel? Okay, so are they in series? Now these three resistors are connected and the current is not dividing anywhere. So whatever the current is going through 5 ohms is going through 10 ohms is going through 15 ohms. So are they in series? Yes, they are in series. Okay, now what do we know about current in series? When you have three series resistors, the current that goes across them is the same. Okay, so the same current that's here is the same current that's here is the same current that's here and the same current that's over here. So the current is not different. Okay, so if that is the case, then how do we figure out what the current is across A, B, C, and D? Okay, so now let's go through that real quick. Okay, now if we go through IR, our voltage is 30 volts. We don't know what the current is, and the resistor is, they're all in series, so that's 5 plus 10, 15, 15 plus 15 is 30 ohms. So our current is equal to 1 amp. Okay, so the answer is quite straightforward. We have 1 amp across all the four different points, A, B, C, and D. Okay, so I want to make sure you guys understand this, that resistance that is in series, okay, the current that's going to flow through them will be the same across all points. It's not going to be any different. Okay, now the next problem we're going to go through is going to be something similar. Okay, now what we're going to do is find a way where um, they will give a variety of different schematics that are really meant to confuse you. So let's take an example of a few of them. Okay, so let's take the following. So you have one resistor here that's connected to another resistor. Okay, now when you look at this particular resistor, they've changed the schematic of the resistors here, but what exactly are they? Are these resistors are in series or are they in parallel? Okay. Now, in order to do that, the first thing you need to think about is trace the current flow. So we're going to trace the current flow here. Okay. So, well, let me first put the question down. Are they in series or are they in parallel? So now let's see if we can trace the current flow. So we know the current flows through from positive to negative. That's a conventional current flow. So we have a current flow that's going through here. It passes through this resistance. We'll call it R1, continues down, passes through resistance R2, and it continues down, does not split in any way whatsoever, then goes through R3, continues, and makes its journey all the way down to the negative. So at any point in time, did you see that the current split from two wires? No, it does not. Just the fact that it's essentially on a visual picture put together so that it looks like a parallel circuit doesn't really make it a parallel circuit. Okay, so current doesn't split anywhere, so therefore we know that this particular resistance sequence is essentially in series. Okay, so I hope this gives you guys a better idea in terms of how the examiners may trick you across a variety of different types of circuit diagrams. Okay.